Hi everybody, today we're going to start a new unit on linear systems. So when you hear the word systems, usually the first thing that should come to mind is that there's more than one object that we're dealing with. When we're thinking of the solar system, there's planets and they all interact with each other in a particular way. Okay, well the same thing is going to work for our linear equations. In order to have a system, you need more than one equation. Okay, so as always, I will leave this exploration part to you, so go ahead and pause the video and go through this example, as this will really solidify your understanding of what systems are. Okay, all right. Okay, welcome back. Hopefully everybody got through that okay. Again, we're going to work with those examples from the exploration section, and we have two equations. Okay, we have 3x plus y equals 11, and we have 2x plus 3y equals 12. Well, if we look at these equations individually, they're all going to have many solutions, and as a matter of fact, they're both going to have an infinite number of solutions. But a few of the solutions can be when x equals 1, y equals 8 for this first one, or when x equals 2, y equals 5. And the way we check that, obviously, we plug those two numbers in for x and y, and hopefully your equation matches up. Your left side equals the right side. Okay, then we have when x equals 3, y equals 2. Now this second equation is going to have different solutions. Okay, when x is 0, y is 4. When x is 3, y is 2. When x is 4.5, y is 1, and so on. Again, you can have an infinite number of solutions. However, there's only one solution that's going to work for both of those equations, and that is this combination here. When x equals 3, y equals 2 will work for both of the equations, and that is the only set of coordinates that is unique in that way. Okay, so that we call that a solution in math when you have a set of coordinates that works for more than one equation. So these equations considered at the same time are called a system. Again, you need more than one to have a system. You can have 3, 4, as many as you want. Okay, we're mostly going to be dealing with two equations. Okay, so again, the solution is the coordinates that work for both that satisfy each equation. Okay, and then graphically, the solution is just obviously the point where they intersect those two lines when you graph them. All right, let's go on here to example number 1. So a system of equations has been represented on the grid. So now we're looking at it graphically. And again, there's only one set of coordinates that both of these graphs are going to share, and that's obviously the point here where they intersect. So that's 2 and -1. Okay, that coordinate there, 2 comma -1, is going to satisfy, meaning that coordinate is going to be on both graphs. Okay, so write the solution as an ordered pair. That's it right there. Okay, let's move on here. So consider the system of equations 2x plus y equals 2 and x minus 3y equals 15. Graph the system without technology. So again, in order to graph this, let me just make this a little bit bigger. Okay, so in order to graph this, again, this is from going back to the last unit. I'm just going to rearrange these into y equals form. So y equals negative 2x plus 2 for the first one, and negative 3y equals negative x plus 15, y equals x over 3, or 1 over 3x, plus, I should say minus negative 5, because I'm dividing everything by negative 3 there. All right, so now that I have it in y equals form, this can be 1 and this can be 2 here, just so we're clear. So I'm going to go ahead and graph those. So there's my y-intercept of 2, and the slope is negative, so it's going to go down 2, 1 over, down 2, 1 over, and then again, as soon as you get your several coordinates, you can just graph the line. This one down here is going to be negative 5, so it's going to be up 1 over 3, up 1 over 3, over, where am I here? Sorry, up 1 over 3 is over here, up 1 over 3, and there's line 2, line 1. Okay, so state the solution of the system of equation. Well, the solution is going to be, again, where those two lines intersect. So the coordinates that work there are going to be, what is that, 1, 2, 3. 3 comma negative 4 is the solution. Okay, and then algebraically verify the solution by replacing the values in the original equations. Well, let's go ahead and check that out. So if x is 3, I'll make this 3, and y is negative 4. Okay, hopefully that works out. Okay, so negative 2 times 3 plus 2, negative 4 equals negative 6 plus 2, negative 4 equals negative 4. All right, it works for that one. Over here I have y equals negative 4 equals 3 over 3 minus 5. So that's 1 minus 5 is negative 4, and we're good to go there. Okay, so that's algebraically how to do it, just by plugging in the numbers and the visual way, the graphical way, I should say. Okay, now let me just show you that example using the calculator, and I'm going to combine these two sections, all of these steps here, with this equation over here. So again, consider the equation, the same equations, and it wants us to rewrite them in slope y-intercept form. So let me first go ahead and do that. So this one's going to be y equals negative 3x plus 11. And then this one is going to be, let me just solve this one. So 3y equals negative 2x plus 12. Y equals negative 2 over 3x plus 4. Okay, so use a calculator to graph them. So let me pull out my calculator here. All right, so again, remember, how do we graph here? Y equals, let me get into here. So negative 3x plus 11, that's y1. And negative 2 divided by 3, 2 divided by 3, and I'm going to just go, let me actually rewrite this a little better just in case we don't want to make a mistake here. So I'm just going to go negative 2, put that in a bracket, there we go, times x plus 4. So if you have a fraction, just put it in a bracket like that, just so you're not, just so the calculator doesn't think that you're dividing by the x if you put it just next to the 3. So always put that in a bracket there. Okay, let's go ahead and go zoom standard, zoom 6 to get our window to the standard window. Okay, so now we have a system here, and clearly, you know, there's a solution to the system, and that solution is where those two graphs intersect. State the suitable window for which shows both x and y intercepts, and let me just move off to the side, and the point of intersection. So let me just change it around a little bit just so we can see it. Okay, I'm going to get rid of the x negative there because I don't really care about all that stuff on the left. Increase my y max to 15. Let's see what that does. Okay, there's that's a little bit better now. I can see both my y and x intercepts and the point of intersection. Okay, so now let's go down to this main question here. Solve the system of the equation using the features of the graphing calculator. So again, so visually you can kind of eyeball that. You can maybe say that's 1, 2, 3, 3.5, and you know, this, my scale is not very good, so if I change my scale on the y-axis to, I can go up by 2s, that might be a little bit better. This is going to be a decimal, which I don't really, you know, it's going to be hard to visually, so I can't really accurately predict my intersect, but the calculator does this for you. If you go into your options here, your calculation options, so go second function, calculate, and under 5 is where you get your intersection. And then the, you know, if you have 10 curves on here, 10 equations, the calculator wants to know which ones are you interested in. So the first curve, the cursor is highlighted there, I'll hit enter. The second curve, well, I only have 2 here, so it's fairly easy. And then finally guess, and I hit enter, and there it is, 3, 2. Actually, they're not decimals, so I was mistaken there. So the equation is the solution is 3, 2. Okay, I'm going to skip to example number 4 just to show you another calculator trick here. So let me go ahead and write these into y equals form. Just give me a second. Okay, so I just rewrote these. Again, don't get thrown off by the a's and the b's here. Y and X, those are just variables. Remember, your Y and X axis can be anything. This can be apples and bananas, whatever it is, it doesn't matter. The point is you want to be consistent by putting them both in terms of B or both in terms of A. Okay, let me get my calculator out now that I have them in that form. So let me go ahead into here, clear these guys out of the way. And the first one is going to be -6. Let me just again put the bracket on here. That's important. So -6 divided by 7 is the slope. -6 over 7 times x plus 5 over 7. That's the first one. So you're going to see here now, we're dealing with we're going to be dealing with some fractions here as a solution. So 3 divided by 14. Use the brackets. Times x. Okay, now I'm going to go zoom 6 just to get my standard window. All right, there's the first one. And there's the second one. And let me just zoom in there just to see what's going on, because my solution is right around the origin there. So let me make everything negative. I might just go -3, 3, -3, 3, just to zoom in on that area, just to see exactly where my intersection is, my solution. And I can see that it's going to be a decimal there. So when I go into my calculation, under number 5, I'll get the intersect, first curve, second curve, enter, enter, enter. Okay, so I get my solution is 0.66 repeating. What was the y coordinate, comma, 1.142, 0.142, and and so on. So now I'm getting I'm getting decimals as my solution here. So the question is, list these answers as exact values. And let me just show you the calculator little trick here that you can do that really quickly. So what you're going to do here is you're going to go so once you have your intersection, you're going to get out of the equation by hitting clear twice, and then you're going to go into math, and see the first option is fraction. Hit enter, and what it does is it takes the answer and turns it into a fraction for you. So 2 over 3. So that's going to represent the x there. So that 0.666 is, as you probably all figured out, is 2 over 3. Okay, and the y is going to be a little bit different. The y one, the procedure is, see under here, under the green buttons, you have the y key. So you're going to go into alpha, select the y, and then the same option. So go math 1. So you're going to turn the y value into a fraction, enter 1 over 7. Okay, so 1 over 7. So that's the exact values of the ones above here. Again, you can verify that algebraically by substituting this for A and this for B in your above equations. And I'll let you go ahead and do that. All right, thanks for watching, guys, and see you next time.